Hi again, everyone. Welcome back to our statistics class notes, and we're still here in the middle of page 131, section 8.3, and we just got done discussing how a confidence interval can lead us to the same type of conclusion as a two-sided hypothesis test. So I want to go through that and show you how that works. In 2015, the Pew Center estimated that 56% of Americans support the death penalty. So this is information from the past, so we're assuming that P, population proportion, is 0.56. In 2016, a Pew Center poll found that 49 support the death penalty. So later, we see that it's less, right? And so our alternative hypothesis that we think this data might be able to show us is that P is less than 0.56. So again, let's suppose the 2016 poll was conducted on a random sample of 1,201 respondents. Do we have evidence that support of the death penalty has changed among Americans since 2015? We're going to conduct a hypothesis test at a significance level of alpha equals 0.05, and then we'll construct a 95% confidence interval and explain how the confidence interval supports the conclusion of the hypothesis test. Okay, so we're going to actually do a two-sided because this data, even though it would suggest that the alternative would be that P is less than 0.56, I want to do a two-sided, which actually a two-sided hypothesis test means you need a test statistic even further away to see you have enough statistical information to support the alternative. But this is what's going to be equivalent to a confidence interval, so I want to make sure we do a two-sided. So P is not equal to 0.56. So the first thing we do in our preparations phase, the second phase of doing the hypothesis test, is we check the central limit theorem. So random independent sample, n times p naught, or the number of successes we would expect in the sample, is 673 here. And n times 1 minus p naught, or the number of failures we would expect in the sample, is 528. So we certainly have a large sample, both of these bigger than 10. And of course, 10 times n, which is 12,010, is certainly less than the American population, so it's a big population. So I'm not going to show you again on how to do the hypothesis test. I've showed you a few times, but you set that in there. Your 588 is your successes using StatCrunch. Your number of observations is 1201, so then you go to your click on hypothesis test with p equal 0.56 and the alternative of not equal to 0.56, and these are the results. So your sample proportion, again, 49% was rounded up in the notes, but we have in the problem written problem statement. But because I had to round the count back down to 588 successes, then it gave a sample proportion of 0.4896. So not quite 49%, but we can't put a decimal in here for the count. Standard error of 0.0143, which gave a z-score of minus 4.92. Again, very far from what we assumed to be the middle of our normal distribution, which is 0.56. So that test statistic is very unlikely to get if 0.56 were really the middle of our normal distribution, giving a p-value of 0.001, less than 0.001 in both tails. Okay, so the interpretation again is since the p-value is less than alpha, we reject HO. Thus, there is sufficient evidence. There is enough evidence to support the alternative. That is, support for the death penalty by all Americans changed from 2015 to 2016. Now, if we construct a confidence interval, so again, instead of choosing a hypothesis test with StatCrunch, and when I go to Stat, Proportion Stats, one sample with summary, instead of choosing hypothesis test, I choose confidence interval, and this is the confidence interval. I get a lower limit of 0.4613. and an upper limit of 0.5179. Again, this is a 95% confidence interval. So we are 95% confident that the proportion of Americans who support the death penalty is somewhere between 0.4613 and 0.5179, which is 46.13% and 51.79%. So since 56% is above this, not inside this confidence interval, it supports the same conclusion of the hypothesis test, which is that we have enough evidence to reject that p is actually equal to 0.56 and it's different than 0.56.